On the board, I have an important definition and an important test for concavity. A point C comma f of c, where the graph of a function has a tangent line and where the concavity changes, is called a point of inflection. Looking at the graph of y equals x cubed and thinking about our last video. On the left-hand side of the origin, I see a concave down shape, and on the right-hand side, I see a concave up shape. At the origin, there is a horizontal tangent line. So I meet both conditions, that there is a tangent line and the concavity changes. So for y equals x cubed, I can tell you for sure there's a point of inflection at 0, 0, the origin. For y equals the cube root of x, on the left-hand side, I see a concave up shape, and on the right-hand side, I see a concave down shape. At the origin, I actually see a vertical tangent line, which actually makes sense because these are inverse functions for each other, but that doesn't really matter for this video. I have a tangent line. The first derivative does not exist at this point, but I have a tangent line. It just happens to be vertical, and the concavity changes. So I can tell you the point of inflection is at the origin. In my last example, by inspection, I see a concave down shape and a concave up shape, but there is no point of inflection, because the graph of y equals 1 over x has a vertical asymptote at the origin. There is no tangent line at the origin. So I can't claim there's a point of inflection because we lack this part. I changed concavity at the asymptote, but there is no point of inflection. Okay, the second derivative test for concavity lets us test for concavity without just having to visually inspect for it. What I know is when I have a region that's supposed to be concave up, my slopes are supposed to be increasing. Well, the slopes come from the first derivative. Well, that's a function. Functions increase when their derivatives are positive. If the second derivative, the derivative of the first derivative, is positive, then the graph of f of x is concave up on I. If f double prime is less than 0, then the graph of the function f is concave down on I. The sign of the second derivative tells us whether the first derivative is increasing or not, telling us whether we're concave up or concave down. Let's do an example where we actually check for concavity in the next video.